Today we are going to continue our topic indefinite integration. This is lecture number 6. Today we are going to discuss the new method of integration. Already we have discussed two methods, integration by decomposition and integration by substitution. Now we are going to start integration by parts. What is integration by parts? In differentiation, you have a direct formula for differentiating product of two functions. You have d by dx of u into v, where u and v are functions of x, is equal to u dv by dx plus v du by dx. All of you are aware of this formula, or you can write d by dx of product of two functions f of x into g of x is equal to f of x into g dash x plus f dash x into g of x. We differentiate g of x first, keeping f of x as it is, then we differentiate f of x keeping g of x as it is, and we add. But in integration there is no such formula directly. If you want to integrate f of x into g of x, it is not integrating f of x and integrating g of x independently. So what is the method? We are going to derive a formula from this. If u and v are functions of x, then d by dx of uv is equal to u dv by dx plus v du by dx. Now let us cancel dx, then you will get d of uv is equal to u dv plus v du. After cancellation of g of dx, you need to understand that d of uv means derivative of uv, dv means derivative of v, du means derivative of u. Okay? Now u dv is equal to d of uv minus v du. Now integrating on both sides, integral u dv is equal to integral d of uv minus integral v du. What is integral d of uv? Integral d of uv means integral of 1 with respect to uv. Integral 1 dx is dx. So integral of d of uv is uv minus integral v du. So we get integral u dv is equal to uv minus integral v du. This is the formula used for finding the integral of a product. This is called integration by parts, if you integrate a product of two functions using this formula. But it is not a product. That formula is integral u dv is equal to uv minus integral v du. Let us see how to apply this formula for the integral of a product of two functions. Let us take a simple example. Integral x e power x dx. It is a product of two functions, and also they are dissimilar functions. So we cannot decompose this, or we cannot substitute anything because they are dissimilar functions. So when there is a product of two dissimilar functions, The only method is integration by parts. First we need to write this in the form of u dv. We know that e power x is the derivative of e power x. D by dx of e power x is e power x. So, d of e power x is e power x dx. So, we can write e power x dx as d of e power x. Then this will be integral x d of e power x. Now, it is in the form of u dv. So, if you want to integrate by parts, first you should write the integrand in the form of u dv. Now, what is u x? V is e power x. So, apply that formula. uv is x into e power x minus integral v du. What is v? E power x. There du means derivative of u. What is the derivative of x? 1. 1 into dx. D by dx of x is 1 into d by dx of x is 1. So, dx is 1 into dx. Now, what is e power x into 1? E power x. Integral e power x is e power x. So, it will be x e power x minus e power x. We write plus c. We do not need to write plus c in every step. We can write plus c in the last step. See, this is the method. But instead of writing some function into dx as d of something, we can have a direct formula. If you want integral f of x into g of x dx, first I will write, keep f of x as it is. G of x dx can be written as d by dx of if you want to write g of x dx as d of something, we know that d by dx of integral g of x is what? Derivative of the integral is the same function, it is g of x. So, cross multiplying we get g of x dx is in d of integral g of x. So, it is f of x into d of integral g of x dx. Now, it is in the form of u dv. What is the integral now? Integral u dv is uv minus integral v du. uv is f of x into v integral g of x minus integral of v du. v is integral g of x dx into du means d of f of x. What is d of f of x? F dash x into dx. Okay. So, you can remember this formula and directly integrate it. But here if you do not know the integral of g of x, it is not possible. It is not possible to write it like this. So, among the two functions, you should take the function which is integrable, whose integral is known as g of x, and that can be written like this. So, among the two functions, select one function which is integrable as g of x. Usually, we call this as first part, g of x as second part, or first function and second function. And first function can be called as differentiable function, because in the formula you are differentiating it. You know that differentiation is not a problem. For any function we can find the derivative, but you cannot integrate every function. Okay. That is why you should carefully select the second function. First you should select second function which is integrable, automatically the other function will be first function. So, this is differentiable function, this is integrable function. So, we can remember this formula as integral of f of x into g of x dx is equal to this is first, this is second, I am selecting. Based on the two functions you have to select. Then you should remember as its integral is first function into integral of second function minus integral of derivative of first function d by dx of first function into integral of second function. Then finally you should write d to dx. So, all of you remember the formula as integral of a product is first function into integral of the second minus integral of derivative of the first function into integral of the second. Okay. Now, examples, one example already we did, that is integral x e power x. Here both can be differentiated, both x and e power x can be differentiated. And you know the integral of x, what is it, x square by 2, you know the integral of e power x. Which is preferable as second function? It is e power x, because when you integrate x, power is increasing. Okay. So, we select e power x as second function, x as first function. Then first function into, that is x into integral of the second function, integral of e power x is e power x minus integral derivative of the first function, derivative of x 1 into integral of second function e power x dx. Then integral e power x is e power x, no? So, it will be x e power x minus e power x plus c. Okay. Let us solve some more problems. Another example, integral 1 by x square into ln 1 plus x. Then we have to select the second function which is integrable. Do you know the integral of ln 1 plus x? Actually, if you remember, among the standard results we have which we have discussed in integration, we have discussed the integrals of sin x, cos x, tan x, cos x, cot x, secant x, cosecant x. We have discussed the integrals of a power x, e power x, x power n, etc. But we have not yet discussed some integrals. Integral of ln x we have not discussed. Integral of some inverse functions we have not discussed. Okay. So, as of now we do not know the integral of ln 1 plus x. So, ln 1 plus x is not integrable. So, we cannot take it as second function. Not integrable means as of now there is no direct formula for integral of ln 1 plus x. So, we select 1 by x square as second function, because its integral is 1 minus 1 by x, and also power decreases, power of x decreases. So, we select ln 1 plus x as first function, 1 by x square as second function. So, now integral 1 by x square into ln 1 plus x dx is equal to first function into integral of the second. First function is ln 1 plus x into integral of the second. What is the integral of 1 by x square? minus 1 by x. So, into minus 1 by x means it will become minus 1 by x into ln 1 plus x minus integral of f dash x, derivative of the first function. What is the first function? Ln 1 plus x. Its derivative is 1 by 1 plus x into integral of the second function. Integral 1 by x square is minus 1 by x dx. Now, first term as it is minus ln 1 plus x by x, minus of minus is plus, integral 1 by x into 1 plus x. How to integrate 1 by x into 1 plus x? We have already discussed the partial fractions method. We have to express it as partial fractions. For expressing it as partial fractions, we can write numerator 1 as 1 plus x minus x by x into 1 plus x. Now, separating the denominator, you will get minus of ln 1 plus x by x plus integral 1 plus x by x into 1 plus x is 1 by x minus x by x into 1 plus x is 1 by 1 plus x dx. What is the integral of 1 by x? Ln x. Integral of 1 by 1 plus x, ln 1 plus x. You can write ln a minus ln b as ln a by b. So, final answer is minus ln 1 plus x by x plus, what is this? Ln x by 1 plus x, ln mod x by 1 plus x plus c. So, this is the integral of 1 by x square into ln 1 plus x. But if you feel uncomfortable for while selecting first function and second function, you can remember one rule, that is called ILATE rule. You can easily remember and you can easily take first function and second function without much thinking according to this rule. I represents inverse function, L represents logarithmic function, A represents algebraic function, T represents trigonometric function, E represents exponential function. Okay, the functions are of these types only. Now, in the product f of x into g of x, f of x and g of x belong to these 5 categories. Then follow this rule and take first and second functions in this order. Suppose you have logarithmic and algebraic function, then automatically logarithm is first function, algebraic is second function. Suppose you have inverse and trigonometric, then inverse is first, trigonometric is next, second function. Suppose trigonometric and exponential functions are there as f of x and g of x, then take trigonometric as first function, exponential as second function. Understood? Suppose logarithmic and exponential function are there, then logarithmic is first, exponential is second. Okay? So, without much thinking, you can select the first function and second function. Now, let us solve problems. Integral x sin x dx. X is algebraic, sin x is trigonometric. Usually, we apply integration by parts for finding the integral of product of two dissimilar functions. Okay. Algebraic and trigonometric are dissimilar. Among them, which is first function according to ILATE rule? Algebraic and trigonometric. Algebraic is first, trigonometric is second. So, this is first function, this is second function. Now, apply integration by parts. It is equal to first function into integral of the second function. What is integral sin x? Minus cos x. Minus integral derivative of the first function into integral of the second. Derivative of the first function is 1. Integral of the second function is minus cos x into dx. Now, x into minus cos x is minus x cos x. Minus of minus is plus. What is integral cos x? Sin x plus c. That is all. Another example, integral x square cos 3x. Again algebraic and trigonometric. Algebraic is first, trigonometric is second. Okay. Integral x square cos 3x dx, first function into integral of the second, x square into what is the integral of cos 3x? Sin 3x by 3. First function into integral of the second minus integral derivative of the first function, derivative of x square is 2x into integral of the second function sin 3x by 3. Dx. Now, you do not have the integral of this directly. Again, it is a product of two dissimilar functions. So, what to do? Again, we have to integrate this product by parts. It is x square sin 3x by 3 minus, you can write 2 by 3 outside the integral, integral x sin 3x, and this should be integrated by parts. Now, which is first function? X, algebraic. Second function is sin 3x. X square sin 3x by 3 minus 2 by 3 into, we are integrating by parts, first function into integral of the second. X is first function, integral of second function, what is the integral of sin 3x? Minus cos 3x by 3. Minus integral derivative of the first function, derivative of x is 1 into integral of the second function minus cos 3x by 3 dx. Now, x square sin 3x by 3 minus of minus plus 2 by 9, 3 into 3 is 9 into x cos 3x. Next is minus of minus is plus, again into minus is minus. Let us write directly. What is the integral of cos 3x by 3? Integral of cos 3x is sin 3x by 3. So, I will write Directly integral of cos 3x is cos 3x by 3 is sin 3x by 9 plus c. This is the final integral. Suppose this is x cube, then again after integrating by parts 2 times, again you will get a product. So, whenever you get a product of integral of a product, you keep applying integration by parts formula. Okay. Next example, integral x cube into e power 2x, algebraic and exponential. According to ILATE rule, algebraic is first and exponential is second. So, first function into integral of the second e power 2x by 2 minus integral derivative of the first function, derivative of x cube is 3x square into integral of the second function is e power 2x by 2 dx. Again this is integral of a product, we have to integrate by parts. It is x cube e power 2x by 2 minus, you can write 3 by 2 outside, bracket begin, x square is first function, e power 2x is second function, integrate by parts. In first function into integral of the second e power 2x by 2 minus integral derivative of the first function 2x into integral of the second function e power 2x by 2. Again this is integral of a product, cancel 2, we have to integrate by parts again. This is x cube e power 2x by 2 minus 3 by 2 into 2 4, 3 by 4 x square e power 2x minus of minus is plus 3 by 2 into integral of x e power 2x, integrate by parts, x is first function, e power 2x is second function, first function into integral of the second minus integral derivative of the first function 1 into integral of the second function e power 2x by 2 dx. Okay. Now finally last term is integral e power 2x by 2, which can be directly calculated by using the formula. This is x cube e power 2x by 2 minus 3 by 4 x square 2x plus this into this 3 by 4 x e power 2x, 3 by 2 into 1 by 2 here minus 3 by 4 into integral of e power 2x is e power 2x by 2. So this becomes 8 plus c. This is the final answer. Next, so far we have not discussed the formula for integral of ln x or log x. Now, those functions which are not having the integrals in the previous methods can be integrated now by using by parts. So, I am going to calculate integral ln x dx by applying integration by parts. But you must be wondering, integration by parts can be applied only for integrating product of two dissimilar functions, but it is not a product at all. There is only one function. How can you integrate by parts? In this case, we take the given function as first function because we do not know the integral, that is why we are solving this question. So, take ln x as first function and 1 as second function, take into 1. Ln x is first function, 1 is second function. Then first function into integral of the second. What is the integral of 1? X. I will write x this side, x into ln x, minus integral derivative of the first function is derivative of ln x 1 by x into integral of the second function, that is x dx. Now this x cancels, it is integral 1. What is integral 1? X. So x ln x minus x plus c, or we can take x common and write ln x minus 1, log x minus log a minus log b is log a by b, no? We can write ln x minus 1 as ln x by e. 1 can be written as ln e. Ln x minus ln e is ln x by e. So this is the formula for integral of ln x. Okay. Next, integral tan inverse x. We have not yet derived the integrals of tan inverse x, sin inverse x, etc. We can now derive by using integration by parts. Integral tan inverse x. Over here, first function is tan inverse x, second function is 1. Okay. Integrate by parts. First function into integral of the second, tan inverse x into integral of 1 is x, minus integral derivative of tan inverse x, derivative of the first function 1 by 1 plus x square into integral of the second function x dx. Now, how to integrate x by 1 plus x square? Derivative of 1 plus x square is 2x. So, multiply by 2 and divide by 2. We can multiply inside and divide outside because 2 is a constant. Now, what is it? F dash x by fx. Derivative of 1 plus x square is 2x. What is integral of f dash x by fx? Ln mod fx. So, it is x tan inverse x minus half into ln 1 plus x square plus c. I am not writing mod because 1 plus x square is already positive, always positive. So, this is the integral of tan inverse x, but usually we do not treat these results as formulae. Integral of tan inverse x is this, but it is of no use, just it is a problem, not a formula. Similarly, even integral of ln x need not be considered as formula, okay? It is just a problem. Now, I will tell you one shortcut formula for integrating x power 4 sin 3x. Here in the usual method, we have to take x power 4 as first function, sin 3x as second function, integrate by parts. Again you will be getting product of two functions at the end. Again integrating by parts, x cube becomes x square. In this way we have to integrate it by parts 4 times. But in my shortcut method, you will be able to write the answer in one step. The method is, when the first function is in the form of x power n, second function is either sine function, this must be algebraic, algebraic means in the form of x power n. The second function must be either sine function or cosine function or exponential function, then only we can use this shortcut formula. The formula is, let us call this as first function, this is second function, or this is differentiable function, this is integrable function. Okay. You write the differentiable function and go on differentiating it as far as possible till you get a constant. What is the derivative of x power 4? 4x cube. Keep some distance, write its derivative. Again keep some distance, write its derivative. What is the derivative of 4x cube? 12 x square. Again differentiate, 24x. Again differentiate, 24. After that it will be 0. So differentiate the first function as far as possible. Now take signs alternately starting from plus signs. First sign plus, next minus, plus, minus, plus. Then multiply by the integrals of the second function continuously. What is the integral of sine 3x? Minus cos 3x by 3, multiply by this first one. Again what is the integral of minus cos 3x by 3? It is minus sine 3x by 9, multiply here. Again integrating minus sine 3x by 3, what we will get? Minus sine 3x by 9, we will get cos 3x by 27. Again integrating cos 3x by 27, you will get sine 3x by 81. Again integrating sine 3x by 81, you will get minus cos 3x by 243. That is all. This is the integral of that. You can simplify, you can cancel the common factors, you can minus into plus is minus. Now you simplify. This is the method of writing the integral of x power 4 sine 3x in one step. We have already solved one or two questions in finding the integral of algebraic and exponential, algebraic and sine function and cosine function. Let us go back and verify. See here algebraic and exponential, we can use the shortcut. What is the shortcut? First differentiable function, x cube, go on differentiating it as far as possible. What is the derivative of x cube? 3x square, again differentiating 6x, again differentiating 6. Then starting with plus sign, plus, minus, plus, minus. Then you should go on multiplying by the integrals of the second function. What is the integral of e power 2x? E power 2x by 2. Again integrating e power 2x by 2, you will get e power 2x by 4. Again integrating e power 2x by 4, e power 2x by 8. Again integrating e power 2x by 8, you will get e power 2x by 16 plus c. Now check with this. This term is same, this is same, this is 6 by 8 is 3 by 4, this is same, and 6 by 18 is 3 by 8. So, we got the same answer. Okay. Now, let us solve one more question on this shortcut formula. Integral x cube into 2 power x dx. 2 power x is also exponential function. First, x cube, go on differentiating it as far as possible. Derivative of x cube is 3x square, then derivative of 3x square 6x, again derivative of 6x 6. Now, multiply by the integrals of the second function, that is e power x, 2 power x. Integral of 2 power x is what? 2 power x by ln 2. Again integrating 2 power x by ln 2, you will get 2 power x by ln 2 whole square. We have forgot to write the signs, plus, minus, plus, minus. Then again integrating 2 power x by ln 2 whole square, you will get 2 power x by ln 2 whole cube. Again integrating 2 power x by ln 2 whole cube, 2 power x by ln 2 whole power 4 plus c over. This is the integral of x cube into 2 power x. Now, we are going to discuss some more formulae. Integral e power x into f of x plus f dash x dx is equal to e power x into f of x. How? You can check the derivative of e power x into f of x is by product rule, derivative of first function e power x into f of x plus e power x into derivative of f of x, e power x into f dash x. Now, taking e power x common, it becomes this. So, integral of e power x into f of x plus f dash x is e power x f of x plus c. This is a formula. But why is it given in integration by parts? Because it is not deriving from differentiation. We have to derive it using integration by parts. If you want to derive it using by parts, take integral e power x into f of x dx. We do not know what is f of x, what kind of function is f. So, we do not know whether f of x has integral or not. So, we take f of x as first function, e power x as second function. Then integrating by parts, first function into integral of the second. First function is f of x into integral of the second function is e power x minus integral derivative of the first function is f dash x into integral of the second function e power x dx. Now, take this second integral this side. If you take it this side, then both are integrals, e power x is common, e power x into here f of x, this minus becomes plus, plus here remaining is f dash x. Is equal to e power x f x. Okay. So, this is the formula which we are going to use in integration by parts. Some examples on this formula. integral e power x into 1 plus tan x plus tan square x. Very simple question. Whenever e power x into something is there, you try to use this formula. Try to write this function in the form of f of x plus f dash x. 1 plus tan square x is secant square x. So, it is integral e power x into tan x plus 1 plus tan square x is secant square x. Now, we know that derivative of tan x is secant square x. So, this is f of x, this is f dash x. So, what is the integral e power x into integral of e power x into f of x plus f dash x is e power x f x. So, it is e power x into tan x plus c. Next example, integral x e power x by 1 plus x whole square. Whenever e power x is there, try to write the remaining function in the form of f of x plus f dash x. Other than e power x, what is there? X by 1 plus x whole square. We have to express it as sum of two functions, f of x and f dash x. For that, you write x as 1 plus x minus 1 1 plus x minus 1 by 1 plus x whole square. If you separate the denominator, e power x into 1 plus x by 1 plus x whole square is 1 by 1 plus x minus 1 by 1 plus x whole square. Now, observe these two. Derivative of 1 by 1 plus x is minus 1 by 1 plus x whole square. So, this is f of x, remaining is f dash x. So, what is the integral? E power x f x is e power x into 1 by 1 plus x, e power x by 1 plus x plus c. Now, the next question, integral sin ln x plus cos ln x. Whenever there is log x without base, we have to take it as the logarithm to the base e in calculus. Integral sin ln x plus cos ln x. There is no e power x, but observe that both the functions are in terms of ln x. Let us substitute ln x is equal to t. Put ln x is equal to t. But when we substitute something as t, its derivative should be there in the integrand. But derivative of ln x is 1 by x, 1 by x is not there. Then immediately you write ln x is equal to t as x is equal to e power t. We can write now. Now, differentiating on both sides, derivative of x is 1 into dx is equal to derivative of e power x e power t is e power t dt. Then integral sin t plus cos t into dx is e power t dt. Now observe that derivative of sin t is cos t. So it is e power t into f of t plus f dash t. What is the integral? E power t f of t. So it is e power t into, what is f of t among the two? Sin t. Now e power t is x and t is ln x. So the final answer is x sin ln x plus c. Now we are going to derive some more formulae. In our previous classes, we have already proved this formula by trigonometric substitution. Putting x is equal to a sin theta, we have proved this. We can also prove this formula by integration by parts. Let us see how. So many problems, so many formulae which we cannot solve by other methods can be solved by integration by parts. Here we take root over a square minus x square as first function and 1 as second function. Then first function into integral of the second. Root over a square minus x square into integral of the second function is x, integral of 1 is x, minus integral of derivative of the first function. What is the derivative of root a square minus x square? 1 by 2 root a square minus x square into derivative of a square minus x square. Derivative of a square minus x square is minus 2x. Okay. Now into integral of the second function. Integral of the second function is x into x dx. Now let us simplify. X root over a square minus x square, minus of minus is plus, integral x into x, x square by root a square minus x square dx. Now what to do? If you continue in this way, it will not be ending with a known integral. So at some stage we have to cut the procedure. What we do is we write this in terms of LHS. How to write? X root a square minus x square plus, we can write x square as a square minus of a square minus x square. See, it is x square only now, by root over a square minus x square dx. Now separating the denominator, x root over a square minus x square plus integral a square by a square root over a square minus x square minus integral a square minus x square by root a square minus x square, that will be root a square minus x square. We can write dx here and another dx here. What is this? This is the asked integral. Let us denote this integral by I. then this last step is x root over a square minus x square plus a square is constant, take a square outside, then integral 1 by root a square minus x square, it is a standard formula, sin inverse x by a minus I. Now taking minus I to left hand side, we get 2I is equal to x root a square minus x square plus a square by 2 sin inverse x by a. Okay. Then dividing by 2, we get this result. Finally, we write plus c. After getting the final integral only, we write plus c. Okay. Similarly, we have proved two more similar results in integration by trigonometric substitution. Those two results are integral root over a square minus x square dx is this, integral root over x square minus a square is this. Observe, only this will have minus sign, remaining two are plus. These two also can be proved by integration by parts. You try to prove these two. Now I am going to prove one more result, very important, you need to remember. Integral e power ax into sin bx plus c dx is equal to e power ax by a square plus b square into a sin bx plus c minus b cos bx plus c. We can prove it integration by parts. Similarly, integral e power ax into cos bx plus c dx is this. All of you need to remember both the results. I am going to prove the first one. Integral it is the product of exponential function and trigonometric function. According to ILATE rule, first function is trigonometric, second function is exponential. Integrate by parts. First function sin bx plus c into integral of second function, integral of e power ax by a minus integral of derivative of the first function. Derivative of sin bx plus c is b cos bx plus c into integral of second function e power ax by a. Okay. Now again we got a product of two dissimilar functions, exponential and trigonometric. So again we have to integrate by parts. E power ax by a into sin bx plus c minus b by a into, it is product of two dissimilar functions now. So we have to integrate by parts. What is first function, what is second function? By ILATE rule, cos bx plus c is first function, e power ax is second function. So bracket begin, first function into integral of second function. Integral of e power ax is e power ax by a. Already we have taken b by a common into e power ax by a. First function into integral of the second function minus integral derivative of the first function into integral of the second function. Derivative of the first function is, derivative of cos bx plus c is minus b sin bx plus c into integral of the second function. Integral of e power ax is e power ax by a. Now simplify, e power ax by a into sin bx plus c minus b by a square into e power ax into cos bx plus c now minus of minus is minus. What you will get, b by a into b by a, b square by a square into what is the integral? Integral sin bx plus c into e power ax, that is the given integral. If you denote this by I, then the last step is b square by a square into I. Now what will you do? Take minus b square by a square into I to left hand side. I plus b square by a square into I is equal to, from these two we can take e power ax by a square common. Into what we will get here, a sin bx plus c minus b cos bx plus c. Bracket close. You can simplify the LHS. Taking a square LCM, you will get a square plus b square by a square into I is equal to this. You can cancel a square in the denominator. Finally, you will get I is equal to, take it that side, take a square plus b square by a square to right side. Then you will get e power ax by a square plus b square into a sin bx plus c plus not plus, minus b cos bx plus c. Similarly, you can prove the other result. Integral e power ax into cos bx plus c dx is equal to e power ax by a square plus b square into a cos bx plus c plus b sin bx plus c. Okay. Let us solve few examples on these two formulae. Integral e power 2x into cos 3x It is directly in the form of e power ax into sin cos bx plus c. So, e power ax by a square plus b square, 2 square plus 3 square, how much? 13 into a cos bx plus c, that is 2 cos 3x plus b sin bx plus c, b is 3, so 3 sin 3x plus c. Suppose the question is asked in subjective type examination, then we have to integrate by parts and solve in our previous method. We have proved this formula, na, integral e power ax into sin bx plus c. In the same procedure, we have to derive the value. Okay. But in objective type problems, you can directly write the formula. Next problem, integral 2 power x into cos x dx. What we do is, we write 2 power x as e power something. We know that any function f of x can be written as e power ln fx. Okay. So, 2 power x can be written as e power ln 2 power x. E power ln 2 power x is e power x ln 2, is it not? So, we write 2 power x as e power x ln 2 into cos x. The previous one was cos, this is also cos. Now, it is in the form of e power ax into cos bx plus c. Then what is the integral? E power ax by means e power x ln 2 by a square plus b square. A square plus b square is ln 2 whole square plus 1 into a cos bx plus c, that is ln 2 into cos x plus b sin bx plus c. B is 1 into sin x plus c, that is all. Now, you can write this as 2 power x. So, this is the final answer. Now, some more time is left, so I would like to explain one nice question. Let us take integral e power x into sin 2x dx. Just now I have explained the method of finding the integral. Suppose it was asked in subjective type, then we have to integrate by parts as same as the proving integral e power ax into sin bx plus c. Now, I will explain you a different method, interesting method. We have already discussed the formula integral e power x into f of x plus f dash x is equal to e power x f x. I want to use this formula and get the answer. Let us assume that sin 2x is f of x. E power x is there, assuming that sin 2x is f of x. What is f dash x? 2 cos 2x. And so that it will be in the form of e power x into f of x plus f dash x. But when you add 2 cos 2x, we have to subtract 2 cos 2x. So this part is over. Integral e power x into f of x plus f dash x, directly you can use the formula. Again the second part is left. What is the derivative of this? If this is f of x, what is the derivative of minus 2 cos 2x? It is plus 4 sin 2x. We will add. Again we have to subtract, but if we continue like this, sin becomes cos, cos becomes sins, it will not be ending. Now you stop here, just adding, do not subtract. If you observe, what happens? This is cancelled, this is 5 times of this. So I will stop here. Since this is 5 times of this, I will write into 1 by 5. So this is equal to this. Now this is f of x plus f dash x. E power x into f of x plus f dash x is a formula. Again this is e power x into f of x plus f dash x is a formula. Then what will get? 1 by 5 into e power x by 5 into integral of e power x into f of x plus f dash x is e power x f x. So e power x into sin 2x plus again e power x by 5 into this is f of x, this is f dash x. So it will be e power x by 5 into minus 2 cos 2x. Now taking e power x by 5 common, we get sin 2x minus 2 cos 2x plus c. This method is allowed in even in subjective examinations. Okay. And one more method I will explain, that is based on complex numbers. In that method, I will write sin 2x as imaginary part of e power 2x. Those who are familiar with complex numbers only can understand this method. In complex numbers, cos theta plus I sin theta can be written as e power I theta, where I is square root of minus 1. So sin here cos theta is called real part, sin theta is called imaginary part. So this sin theta can be written as imaginary part of e power I theta. So I will write sin 2x as imaginary part of e power 2ix. If you multiply by e power x, even if e power x goes inside, it is still imaginary part. So, we can write as e power x sin 2x can be written as imaginary part of e power x into e power 2ix. Then what is it? It is totally imaginary part of e power x into e power 2ix is e power 1 plus 2i into x. Now, you can write this imaginary part outside. So, it is imaginary part of integral e power 1 plus 2i into x. We know that integral e power ax dx is e power ax by a. Here a is a complex number, even for complex constants that is allowed. So, it is imaginary part of what is the integral? E power 1 plus 2i into x by 1 plus 2i. Now, this is in the form of e power I theta. So, cos theta plus I sin theta. Then those who are familiar with complex numbers know how to find the imaginary part of this and they can finish. Many of you are not knowing about complex numbers. So, just I am giving the idea how to solve it in a different method by using complex numbers. So, if you find the imaginary part of this, you will get the same answer. So, I am now going to conclude the class with this, and we are going to continue in the next class with more problems on integration by parts. Okay, thanks for watching. See you in the next class.